In this video, we'll learn about linear sequences. You've heard the word linear before when we looked at linear equations, linear expressions. So what we're going to be doing now is having a look at one of them. So you can see a pattern there. This is a sequence, a linear sequence. If I try and plot it here, you probably will make a connection with another topic that we've covered before. So this is the first term, this is the second term, third, fourth, fifth, sixth, and this continues. So if we have the position here, such as the first, second, third, and so on, and the terms here, so we can plot the first term is 2. The second term is 4. The third term is 6. Fourth term is 8. Fifth term is 10, and so on. So there is a pattern. What we're doing is we add in 2 each time. And I'll just give you a context for this. Let's suppose you've gone shopping and you're buying a number of items. Each item costs £2. So when you buy one item, you pay £2, 2 items 4, 3 items 6, 4, 8, 5, 10, and so on. So the equation of this line would be y equals 2x, where 2 is the gradient. And why did we create an equation? So that we can easily find terms that we can't plot easily. So if I want to find the hundredths term, or if I want to find the cost of purchasing 100 items, then all I do is y is equal to 2 times 100, which gives me 200. And same thing here, if I want to find the 100th term, I can just do 2 times 100 to give me 200. So that's the point of what we call a position to term rule, or the nth term. There is no difference between a linear equation and finding the nth term. The only thing that differs is how we call it and the letters that we use. So I'm using x in here, whereas here I'm going to use n. So I'm going to just say 2n rather than 2x. The reason why there is a change of letter is really unknown, but the principle is exactly the same. So the nth term is 2n, and the term to term rule is at 2, which is what we've shown here. Let's have a look at another example, that of visiting a theme or amusement park. So if I do one ride, I'll pay £15. 2 rides 20, 3 rides 25, 4 rides 30, 5 rides 35, 6 rides 40, and so on. Let me project it here. So 1 ride £15, 2 rides 20, 3, 25, 30, and so on. So you can see the pattern. I'll join the dots. So what do we notice? How much am I paying per ride? The difference between 15 and 20 is 5. Between 20 and 25 is 5. Add 5, add 5, add 5. So the term to term rule is add 5. That is the gradient also. So for 1 unit across, I'm going 5 up. So rise over run is 5, which is the gradient. That is the per item price. That's the fee I'm paying per ride. But that suggests that I'm having to pay an entry fee, because the price per ride seems to be £5. So what is that? If I take away the 5, what would that be? Kind of the 0th term, which is here the y-intercept. That would be 10. And where have we seen that before? We've seen it where it was y equals mx plus c. So the gradient being 5, what is c, that constant value that is the same throughout? That is 10. And that is also the position to term rule of the nth term. 5n plus 10. Which means with this one, I can work out any term as long as I've got its position. So if I want to find the 50th term, I'll go 5 times 50 plus 10. 5 times 50 is 250. Add 10 gives me 260. So if I take another sequence, I'll start with 30, 25, 20, 15, 10, 5, and so on. So what's the term to term rule? What happens from the first to the second term? We take away 5. So that's our gradient. So the nth term will be something like negative 5n. But we're not finished yet, because we've got to go one step backwards. What's that number which we take away 5 to get 30? It is 35. And it's a positive, that's why we write plus 35 here. So with this one, we can try to see whether we've done it right. This was the first term, so if I go negative 5 times 1, add 35. Negative 5 times 1 is negative 5. Add 35 gives me 30. Let's try if I want to find the 12th term. So I'll go negative 5 times 12, add 35. Negative 5 times 12 is negative 60. Add 35 to that gives us negative 25. So we've easily found the 12th term without having to write each and every one of these terms. And that's the point of an nth term. I've just plotted the points here now. And as you can see, the 12th term is negative 25.